All right, in this video, I'm going to be working Algebra 2 Quiz 9.1. And so this is about exponential functions. So we're going to start off by giving a sketch of the graph of y equals f of x. Okay. And 2 to the x that's just going to be standard exponential growth, the regular old-fashioned exponential curve. Positive growth. Okay. Negative of 10 to the x, remember PEMDAS, exponents before multiplication by -1. So it's still going to be exponential growth, but it's going to be negative growth. So it's going to be negative and growing in the negative direction. Okay. 10 to the negative x, that's exponential decay. That would be the same as 10 to the -1 to the x, or 1/10 to the x, and that's going to get smaller, closer to 0. And so I'm going to say it's coming from above. And go like that. And -2 to the negative x, okay, this is a little tricky. This is decay, but negative, so it's going to go towards 0, but from underneath. So, okay. All right, number 2. If 2 to the b plus 3 equals 8 to the 3b minus 2, what's the value of b? Okay, so what we need to do here is write both of these as a power of 2. 2 is already a power of 2. 2 to the b plus 3. We're good there. We're going to need to write 8 as a power of 2. 2 to the 3 is equal to 8. Okay. And so in this situation, in power of a power, I'm going to multiply my exponents. So this would be 9b and minus 6. Okay. Now that I've got an equation like this, two things with the same base and different exponents, I'm going to set the exponents equal to each other and solve. So b plus 3 equals 9b minus 6. Might subtract a b over here to get 8b. Might add a 6 to get 9, and then I might divide by 8 to get b. I'd say b is 9 divided by 8. All right. Now, in a chemistry lab, students measure the amount of substance that's remaining after a reaction. Okay. At the beginning of the experiment, there were 2,000 milliliters of the substance. Okay, so the starting value is going to be 2,000. Okay, now an exponential function a of t is going to equal, okay, so some sort of starting value. Now, I usually call that a, but a is the name of the function. So I'm just going to call this v, like the starting value, times, you know, some sort of growth or decay factor. It'll be bigger than 1 if it's growing and less than 1 if it's decaying, to the t power. Okay, and we want v to be the value of a when t is equal to 0. Okay. So v is going to equal that 2,000, our starting amount. And then the amount that we're multiplying by each time, if we get a recursive formula, they're telling us the amount to multiply by each time. We don't need to worry about 1 plus a percentage or 1 minus a percentage. I'm going to say, okay, 4/5 of the last one gives me the next one. That's the recursive rule. I'm going to say, okay, well, I'm just multiplying by 4/5. Okay. So this is going to be 2,000 times 4/5 to the t. After 1 hour, there's 1,600 milliliters remaining. Okay, well, if I multiply 2,000 by 4/5 to the 1, that's 1 hour, I am going to get 1,600, so that makes sense. It fits. Okay, let's keep moving. So on the back side, the population of a recently opened community college is 1,300. Okay, so when it opened, or right now, it's 1,300. So p of t, all right, so p is going to equal a times, okay, this is a percent growth increase. Yeah, so it's going to be 1 plus r to the t power. Okay. In our case, a is the initial value, so that's 1,300 students. R is the percent growth rate, which is 0.125. That's 12.5%. Right? Move the decimal over twice. And that's all I need. Yeah, p of t is equal to 100 times 1 plus 0.125, so 1.125 to the t. Honestly, in my class, I'm okay if you would leave it as 1 plus 0.125 to the t. Either way, it's the same thing. All right. This one, I think, no, this one worked out fine. It's form B that we had to change, and I think it's actually changed on some, like the one that's on the internet, but maybe not the one that I printed. It was a whole mess. And all right, so the y-intercept on the graph of any function is going to be the value of f of 0. So I'm going to plug in x equals 0, and f of 0 will equal negative 12 plus 3 times 2 to the 0. And I did this for a reason. I wanted to really emphasize, right now we're really emphasizing PEMDAS. Okay. Remember, exponents before multiplication by 3. So this is not 6 to the 0 power. It's 2 to the 0 exponents before multiplication. So 1 from 2 to the 0 times 3. So this is negative 12 plus 3 times 1. And that's going to be negative 12 plus 3 is negative 9. The x-intercept, that's the point where y is equal to 0. So I'm going to set f equal to 0. So 0 equals negative 12 plus 3 times 2 to the x. I'm going to add the 12. I'm going to divide by 3 because I'm trying to access this exponential. We haven't really solved these type of equations yet, but the idea is, isolate the thing with an x and then just look at it and solve. To this point, if you're watching later, we know about logs, we know about all sorts of stuff. We didn't know a whole lot. We were just trying to get it down to 4 equals 2 to the x. And it's like, oh, wait, I know what x makes this true. 2 squared is 4, so x is going to equal 2. Right? And then find the value of f of negative 2, and we're going to give our answer as a decimal number. So f of negative 2, I'm just plugging in negative 2 wherever I see x. Again, exponents before multiplication of any kind, especially multiplication by 3 in this case. So negative 12 plus 3, 2 to the negative 2 is 1 over 2 to the regular 2. So 1 over 2 to the 2 would be 4. Negative 12 plus 3/4 is negative 11/25, right? Right, it's a decimal. If you have to write this as a fraction, fine. I thought I was being generous by telling you to write it as a decimal number. I thought that would make it easier. But a lot of people just gave me their answer as a fraction anyway. Whatever. It's all the same numbers. I'm not the guy that's really caring how you write a number as long as it's the right number. Okay. Form B. We're going to sketch the graph of y equals f of x. Okay, 10 to the negative x, that's exponential decay. Okay, that one was pretty bad. I've drawn much better, but would have gotten the credit. Negative of 2 to the x. That's negative growth because I'm saying 2 to the positive x and then multiplied by negative 1. So it's negative the whole time, but as x gets bigger, it's growing in the negative direction. It's bigger in the positive direction, I guess I should say. All right, negative 10 to the negative x, that's negative decay. So decay being getting closer to 0. Oh, these sketches are pretty bad. Pardon me. I'm doing this again. But in class, how we graded this was like, does it have the right shape? And is it in the right quadrants? Like this one only lives in the first 2 quadrants. This one only lives in the bottom 2 quadrants. If it's got the right shape, right quadrants, we gave it the credit. Okay. This one is an exponential equation we'll be able to solve because 3 and 27 are both powers of 3. So I'll keep that b plus 4 here. And I'll write this as 27 as 3 cubed. Right? And then I need to actually multiply these exponents. Okay. Set the 2 powers equal to each other. Okay, so I'm going to subtract a b. I'll have 14b. Maybe I'll add the 9 at the same time. I'll have 13. And I'll divide both sides by 14, and I'll get b is 13 over 14. All right. Now, in an environmental science lab, students measure the size of a plant after it sprouts. At the beginning of the experiment, the height of the plant was 2 centimeters. At 1 week, the plant was 3.33 centimeters tall. Students continued measuring the height of the plant at 1 week intervals for the rest of the class. They modeled the height of the plant with the recursive formula hn equals 5/3 of hn minus 1. So the height at each week is 5/3 of the height at the week before, is what we're saying. Okay, if we're talking about h of t as an exponential function, I'm just going to say it's some starting value times, okay, well, with a recursive formula, they're actually just giving me the number I'm going to multiply by each time, so I don't even really need to worry about a percent growth or a percent decrease, anything like that. I'm just going to have some number to the t, and in our case, that number is going to be 5/3. Okay, a is like the starting value, the value that corresponds to t equals 0. So at the beginning of the experiment, after 0 weeks, the height of the plant was 2 centimeters. Okay, so I'm going to say my formula is 2 times 5/3 to the t. H of t. All right. On the back side, we've got another one of these like writing equation for the situation problems. And, you know, we graded these in class just earlier today. And I got the message, okay, y'all need more practice on this. You need more experience looking at a situation, writing an exponential function for it. I will make sure to get you that, okay? You look at the review, you look at the later homework, you're going to see that showing up so that you can get the practice you need so that you can answer this problem correctly on the test. Because both of these, like the last one and this one, I made sure to put both of those on the test. So, all right, not exactly the same, not the same context, but one that's got a recursive formula and one's got a percent growth or a percent decrease. Okay, so the current number of students at the community college is 980. Okay. So the starting value is 980. The number of students is going to decrease by 6.5% per year because they're not offering a nursing program anymore. I was trying to think what would cause the population of a college to decrease that would be, something I could put on a quiz, and it's like, okay, well, not offering a degree anymore. Okay, A is 980. Rate is going to be negative 6.5% because it's decreasing. So that's negative 0.065. Okay. P of t, the exponential function, will be some value of a times 1 plus r to the t, where r could be negative if the thing was decreasing. So this is going to be 980 times 1 minus 0.065 to the t. Now in the last one, on form A, it was percent growth, and I added those together and just wrote it. With this type of arithmetic, that's a little bit risky. I'm going to suggest that you just leave it there, right? Because I wouldn't want you to subtract 1 minus 0.065, do it wrong, and then have a wrong answer. You know what I'm saying? That's what I'm getting at here. Okay, this needed to be a 5. Okay, if this was a 5, the problem worked out really well. If it wasn't, did not. Okay, so I'm going to work this one with the 5 there. I think probably on the one that I published on the internet, it says 5. I think I made the quizzes, worked them, caught all the errors, changed them, but I ordered the copies off of the old PDFs. Big mistake. Okay, so find the y-intercept on the graph of f. Okay, y-intercept, that's where x is equal to 0. F of 0 is negative 40 plus 5 times 2 to the 0. Okay, again, exponents before multiplication, PEMDAS. Exponents by 5, this is negative 40 plus 5 times, deal with the exponent first, 2 to the 0 is 1. And then negative 40 plus 5 is negative 35. The x-intercept on the graph of f, that'll be where y is equal to 0. And so f of x is equal to 0 because, f of x represents y. And that'll be when 0 is negative 40 plus 5 times 2 to the x. And then with this one, I'm just solving it 2 to the x, and I get 40 equals 5 times 2 to the x. I'm going to divide by 5. So it's going to be 8 equaling 2 to the x. And I'm thinking to myself, what exponent do I put on 2 to get 8, which is something we've been thinking about a lot in this unit, and that's going to be the 3 exponents. I'm going to say x equals 3. Now, lastly, we want to find the value of f of negative 2 and give our answer as a decimal number. Okay, we can do that. So we're just going to plug in negative 2 for x. So negative 40 plus 5 times 2 to the negative 2 power. And so this is negative 40 plus 5 times 2 to the negative 2. We got to deal with that exponent first before multiplying in the 5. That would be 1 over 2 squared, so that's 1 over 4. Okay. 5/4 is 1.25. So I have negative 3875. I think originally when this was, when it was a 3, it worked out, the arithmetic was a little better because it was 3/4 and didn't have to think about that. But I don't think that arithmetic's too unreasonable. All right, that's all for quiz 9.1 on exponential functions. Thanks for watching this. Hope it helped.